Okay, so we're told that f of x is equal to x minus 1 squared, and we want to find f of 8. So f of 8 is going to be 8 minus 1 squared, and 8 minus 1 squared is the same as 7 squared, and 7 squared is 49. Now we're told that the domain of f, so that's the possible numbers that could be used in f, is all the values of x where x is 7 or more than 7. And we're asked to find the range. In other words, if you input into this function the numbers 7, 8, 9, and fractions as well, you need to find out what numbers will come out. So let's just have a look at what happens when we put 7 in. If we find f of 7, then that's going to be 7 take away 1, well that's 6 squared, which is 36. If we put in a bigger number, so f of 8, well we've already worked out f of 8 is going to be 49, f of 9 is going to be 9 take away 1, which is 8 squared, which is 64. We can see that what's actually happening is that the values of f of x are getting bigger and bigger and bigger. In other words, if x is 7 or more, it means that f of x is going to be 36 or more. So the range is f of x must be greater than or equal to 36. Okay, next one. G of x now is x minus 1, x over x minus 1, and we're told to solve the equation g of x equals 1.2. Well, g of x is x over x minus 1, so we're going to solve g of x equals 1.2. First thing I'm going to do is multiply by x minus 1. That needs to be in a bracket. So if I multiply the left-hand side by x minus 1, the x minus 1 disappears. On the right-hand side, if I multiply by x minus 1, it goes like that. So now x is equal to, removing the brackets, 1.2 times x is 1.2x. 1.2 times minus 1 is minus 1.2. Now what I'm going to do is I'm going to collect the x's on one side. So let's subtract x from both sides. If I subtract x from the left-hand side, so I'm just subtracting x, subtract x from this side, I'm left with 0. Subtract x from the right-hand side, or 1.2x take away x is 0.2x, and that's minus 1.2. If I now add the 1.2 to both sides, I get 1.2 on this side equaling 0.2x, and now I'm going to divide both sides by 0.2. So this side becomes just x, this side becomes 1.2 divided by 0.2. Now you can use your calculator there, or you can realize that if you times the top and the bottom by 10, the top becomes 12, the bottom becomes 2, and 1.2 divided by 0.2 is going to be the same as 12 over 2, which is equal to 6. So x is equal to 6. Right, we're now asked to find the inverse function. So g of x is this function here. So my first step is to write y equals g of x. So y is equal to x over x minus 1. And my job now is to rearrange this to make x the subject. First thing I'm going to do is multiply by that x minus 1 on the bottom. So y times x minus 1 will equal x. Removing the brackets, I've got xy minus y is equal to x. And now I can see that I've got a problem here. I want to make x the subject, but x appears on both sides. So I'm going to collect everything containing x on one side. So first of all, I'm going to subtract x from both sides. So the left-hand side is going to become xy, take away x, take away y is equal to 0. And if I now add that y over onto the right-hand side, so xy minus x is equal to y. Factorizing the left-hand side, x brackets y minus 1 is equal to y. And if I now want to make x the subject, I just need to divide by this bracket. So x will equal y divided by y minus 1. Now remember my inverse function, this is my inverse function, but I've got to swap x and y. So my inverse function is actually x over x minus 1, which is strange, because what's happened is that g of x is x over x minus 1, and g minus 1 of x, so the inverse function is also x over x minus 1. Now that's actually quite important, because because it basically means that g times g minus 1 is always equal, well, that is always equal to x. So g minus 1 of x is also equal to x. But in this case, g minus 1 of x is actually g of x. So g minus 1 of x and g of x are the same thing. So if we're asked to work out g of x, which is what happens in part 2 here, g of x is actually exactly the same as g minus 1 of x, and that's actually equal to x. So in this case, g of x, because g is the inverse of g, it will just take you back where you started to x